So depending on that, good morning, good afternoon. First thing I want to get into is our notes. So today we're going to be talking about real numbers, organizing real numbers, but the first thing I want to do is discuss this. And these are going to be some quick videos. We're going to have discussion time on the Google Meet to get more in depth into this, but I want to give you the general information, but we're going to kind of speed through it. So at any point, if you want to pause, take notes, I suggest you do that. I really want you to be writing all this down. So here's how our notes are going to be formatted. So I can zoom out here and show you. So I'm going to send you this, and when we're in class, I'm going to be giving you this. We're going to use this, and I'm using this to structure the notes for you all. That way you don't have to. In class, obviously, it'll be a little bit easier. When you're at home, I want you to either print this out and take your notes on that, or you can just structure your notes similar to how this page is set up. And you can do it in several different ways. You could just, bear with me a minute. I'm bringing up my tool. I don't know what it's doing. It's not working. That's not good. It's never good. Oh, there we go. Okay. So you could just, if this is your piece of paper here, you could just draw a line down not the very middle, but to the left side. Put all your main points here, notes there. That's a good way to take notes. It helps organize it, helps keep up with it. It's just a very easy way to do it. All right. So like I told you before, we're going to roll through this kind of quickly. I'm going to give you the main points. It's going to be the thing I ask for is that you take good notes. That's why I'm giving you a lot of the information to where you're not having to write it down, because I don't care about if you can write stuff down. I care about if you can remember this information and apply this information. So I'm doing you a big favor by getting all this information to you. So all I ask is that you just write down what I ask you to write down and keep up with it. And that'll be the little deal we make. So let's start off. Let's speed through this. We're going to start off with real numbers. Now, real numbers are notated with this notation. That was a terrible first R. So you can write this together or separate, just kind of something like that, or you can just use an R, to be honest. I don't mind if you use it just like this to remember. First thing we're going to talk about real numbers is, first of all, real numbers consist of every fathomable number that you can think of. Okay, so that's the first thing. So just remember that real numbers are literally every number that you could think of, because later on it's going to ask you to label them. Real numbers should go, or label the examples. Every example should have an R beside it, because every example is going to be a real number, I promise you. Now, inside of real numbers, we have irrational numbers and we have rational numbers. Those are pretty much our two different subsets. Now, irrational numbers are going to be numbers that are in decimal form but can't be written as a fraction. So like the square root of 5, for instance. Square root of 5, if you put that in your calculator, you're going to try to turn it into a fraction. It's not going to do it, I promise you. Or like pi. Pi is 3.14, whatever. It never ends, so it's a non-repeating, but it's a continuous decimal. It's not repeating, but it's not terminating. Okay, so that's going to be our irrational numbers. Now let's go to our rational numbers. So our rational numbers are going to be any number. This is the main thing that I would like you to remember. Any number that can be written as a fraction. So any number that can be written as a fraction, like 2 over 3. So that's going to be a rational number. Or it's going to be a decimal that terminates. So, for instance, 1 over 4 equals 0.25. That decimal terminates. It terminates at 5. So that's going to be a rational number. 2 over 3 is going to be 0.66, and it repeats, or 0.6 and repeats. So repeating numbers also go into rational numbers. Now, inside of rational numbers, we have 3 different subsets. Those subsets are going to be natural numbers. Natural numbers start at 1, and they're all positive numbers, okay? So you could write that down if you wanted to. Natural numbers start at 1 and are all positive numbers. Whole numbers start at 0 and are all positive numbers. So you could write that down as well. If I were you, I probably would. It's an easy way to remember it. And then integers are all negative and positive numbers. But the big thing about all of these is they're going to be all whole numbers. So they're non-decimal or non-fraction. Okay. So all of these here are going to be whole numbers, essentially, as you would know them. They're going to be like 1, 2, 3, negative 1, 2, 3, something like that. Never going to be fractions. Okay. Now, let's look at the notation that we're going to use for these. Okay. So the notation that we're going to use for these irrational numbers is going to be I, rational numbers is going to be Q, integers is Z, and whole numbers is W, and natural numbers is N. I would write all of these down. So I'd pause this and write all these down if you can. And we'll get in more depth to them as we go through the examples. And I'm probably going to make sure that on a test you know that these, I may give you those just so you know. I don't care about if you can remember the exact letters for them. I want to make sure you know which each of them are. That's what I'm more concerned about. All right, so then examples of each, like an irrational number, we said like pi, square root of 5. Rational number is going to be something like 0.34, or I don't know, negative 7 over 11. That's going to be a rational number. Integers. So they're going to be all whole numbers that are either negative or positive. So you got 7. Like say, for instance, we had the square root of 100. Square root of 100 equals 10. So that's what we're more concerned about. So 10 is an integer. So if it gave you this, you would say integer. Whole number is going to be something like 0 because it starts at 0. Say it gave you 20 over 4. You may look at that and say, oh, that's a fraction. That's not a whole number. That's not true because 20 divided by 4 is going to be 5. So 5 is what we're concerned about. 5 is a whole number. So 20 over 4 is a whole number. Well, 20 over 4 simplifies down to a whole number. Natural numbers. Example of that is something like 10. Same process as the one before. If we had like negative or a radical 9, that equals 3. So that's going to be a natural number. Now, over here, this is going to be a chart to help you keep up with these. So all of these numbers are going to be real. Okay, so every single one of these is a real number. Then it's broken up into two different sets. It's going to be our irrational numbers and our rational numbers, which is denoted by Q. Then next we're going to have Z. So that's going to be integers. Let me write it better for you. So Z. Now, that means that every integer is a rational number. That's what these circles mean. So if it's inside of this circle, that means that all of these are going to be rational, and so on. So if it's inside of, say, for instance, you have a natural number here. Our natural number is going to be also a whole number, an integer, and it's going to be a rational number. So that's why I gave you this chart, and that's what it would look like. So pause the video and write that down if you have not already. Now, let's look at some examples real fast. And I'm not going to do all these. Some of these I'm going to leave for us to do in class, and some of these I'm going to leave for you to do on your own if you need some extra help past homework. But you'll have plenty of homework. You'll have about 20 questions, I believe. Yeah, it's about 18. But we'll also do some of these in class as well when we Google Meet. So let's look at, I'm just going to look at the first two. So we have negative 10. So first of all, we know negative 10. We know negative 10, first and foremost, is going to be a real number because every single one of these, all of these, every single one is going to be a real number. Now, we also know that it's negative, so that means that it could be an integer. So, we also know the best way to probably do this is probably start from the top. So we know that's a real number. Now we need to figure out if it's rational or irrational. So negative 10 is a number that can be written as a fraction because negative 10 over 1 is a fraction. And there's no decimals. I mean, it's 0.0. So we know that that's a rational number. Now, inside of rational numbers, we need to figure out if it's an integer, whole number, natural number. Whole numbers and natural numbers are not negative, so we know that it can't be those. Look at integers. Integers can be negative, and they're pretty much negative whole numbers. So, what is it, z? Yep. So it's going to be z, so that's an integer. So those are all for that. Now, number 2 is square root of 30. So if you put square root of 30 in your calculator, you're not going to get well, first and foremost, before we go anywhere else, it's a real number. I always want you to know that. So if we put that in our calculator, then we know it's going to be, not a fraction, a decimal that will not turn into a fraction. So if a decimal never turns into a fraction, it is irrational. And if it's irrational, that's the only thing it can be. So the rest is done with that. Okay. So those are going to be the examples for those. There's obviously more examples, but we'll get more into those. I just need you to know the basic stuff for this. All right. So now we're going to speed through these fairly quickly, but I'm going to need you to write all of these down. So with commutative property, it's just going to be two things added together. So that's what a plus b is. Those can be any numbers. All that means is we can switch the position of those, okay? And the same thing is true for multiplying. Let me move this up so you can see it. Okay. And the same is going to be true for multiplying. So for multiplying, we can switch the positions of those two variables, those two terms, whatever those are. Could be numbers, could be letters, whatever. Then they're going to equal the same thing. That's commutative property. Okay, now associative is similar, except we're going to add in a third variable. So for adding, if it was a plus b, we can add a c on the end. That's going to be the same thing as if we took the a out and added it to the b plus c. And b plus c, a are all just numbers. They could be numbers, they could be letters, they could be whatever. The same thing is true for the multiplication. Okay, that's going to equal the same thing as if we took out the a, multiplied it by b and c. Same exact thing. Now, that's for associative. Now, for identity, we want this. If we have a here, which a can be anything, we want to get a back. So what can we add to a to get a back? It's just 0. So anytime it asks for the additive identity, you just want to say, I want to add 0 to it to get the same thing out. And for multiplication, if we have a here, we want to get a back out. What can we multiply that by to get a again? It's just 1. So for the identity, if it says the additive identity, you know you're just adding 0. If you want the multiplication identity, you're just going to multiply by 1. All right. So inverse is along the same logic, except we've got a here, and we want to get 0 out. So if we start with a or any number, and we want to get 0 out of it, we're just going to take the negative or switch the sign of whatever the first term is. So in this case, if we have a positive a, we want to add by a negative a, and that will give us 0. That's the additive inverse. Now for the multiplication inverse, same thing applies. We want to start out with a or any number. We want to get 1 back out of it. So what can we multiply a by? We're going to multiply it by 1 over a. Now, the easy way that I would remember this is if we had 2 and we wanted to get 1 back, we're going to just flip that, because 2 over 1 is the same thing as what 2 is. We just want to flip that and make it 1 over 2. Okay, and you'll see an example. I'll do an example. All right, so that's inverse. And then distributive, I'm pretty sure we all should know how to distribute. It's just if we have a number, something outside of a parentheses, the way we do that is that we add it, we come and multiply it by both. So a times b plus a times c. Okay, and those are all of those. Pause the video, write those down, because we're going to speed through this. So I'm just going to do the first 2 examples like I did before. And the basics of this is you want to start out, figure out what you're doing in each of these, and then just apply it to the chart we just wrote down. So in this case, we're multiplying. So we know we're not looking at any addition because we know we're multiplying. We also know that we are involved. We've got some parentheses involved, so we know that it could either be distributive or it could be associative. Now, we're not distributing the 5 to this 2 and the 8. We're taking it and we're moving the position of it. So that means it's going to be associative. And I just want you to remember that it's multiplication in parentheses. Okay. Now 14. Now if we look at 14, we're doing some multiplying and some adding. If you're ever multiplying and adding or subtracting, you know it's probably going to be distributive. And if you look at this, if you distribute the 6 to both of those, this is what you get. That's going to be distributive. I'll do 15 as well. So 15, we have something that equals 0. Anytime we have it equal to 0, it's probably going to be the additive inverse. Because if you look at this, we start out with -7, or we start with 7y, and we want to get 0 back out of it. So the only way to do that is this, and so that's going to be the inverse. All right, now I'm going to leave these for us to do in class. Now, last two things here. So this is just a different format of what we were just talking about. So if you go look at the inverse column, this is all this is, except you're actually finding that number. So before we had a plus something to give us 0, and it was -a. They're just simply asking for what that is. So let's run through these first two. Actually, we'll do 3. We may do all of them. So we've got -8. We want to know for addition, what can I add to -8 to make it 0? Okay, so if I add 8 to -8, that gives me 0. Now for multiplication, we want to know what can I multiply by -8 to get 1. So the only difference here is this one's going to equal 0. This one's going to equal 1. So what can I multiply that to give me 1? You're going to need to multiply by -1/8. And you can check all of these by putting them in your calculator. And so those will be the two, that'll be the additive inverse and the multiplicative inverse. Now, fractions are a little bit different, but they're not too bad. So for addition, we want that to equal 0. Don't get thrown off by the fact that it's a fraction. You're just going to minus. To get rid of 2/3, you just take away 2/3. So it's just minus 2/3. Now, we want this to equal 1. So we're going to multiply by the opposite, not really the opposite, more of the reciprocal. So we're going to take 2/3 and just flip it, and we're going to multiply that by that. So we're just going to multiply by 3/2. That'll give us 1. Plug it in your calculator. It'll happen every time. Now, if we have 6w, we want 6w to equal 0. We're just going to, don't get thrown off by the w. We're just going to take away 6w. If we have 6w, just take away 6w. That'll give me 0. And then for multiplicative, we want that to equal 1. So same thing. Just take the reciprocal. So 6w is the same thing as saying like 6w over 1. So just flip it. 1 over 6w. Plug it in your calculator. Well, you can't do a w, but I bet you could do an x. Either way, it's going to equal 1 every time, I promise you. So then, radical 10, square root of 10, don't get thrown off by just treat it as if it were 10 with a radical in front of it. We don't care about the radical. The only thing we care about is that if I have radical 10 there, the way I get it to equal 0 is to take away radical 10, okay? And that'll equal 0. And if we want this to equal 1, we're just going to multiply by 1 over 10. Just take it and flip it. All right, that'll be those. There'll be more examples for you to work too. Last thing, it's the closure property. Hold on. Closure property. Okay. The closure property is simply saying if something's closed, that means that two elements under the same operation end up giving you a answer that is of that same property, operation, whatever, and it will always happen. So let's look at, and if it doesn't do that, that means it's not closed. Okay. So now for these. True or false, and if it's false, give a counterexample. An easy way to remember these is if you can find a counterexample, that means it's false. always true. So let's look at the first one. So integers are always closed under multiplication. That means, can I take two integers, multiply them together, and always get an integer? And the answer is yes, it's true. You can do it for any integer you can find. I promise you'll get an integer out of it. I'm going to do this one as well. So it says irrational numbers are closed under subtraction. Now, can I find a counterexample to that? And the answer is yes. So you could find, this just basically means, can I take two irrational numbers and subtract them and always get an irrational number? And the answer is no, because if I take pi minus pi, that's going to give me 0. And 0 is not an irrational number. 0 is a rational number. Therefore, this is false. Okay? So we just proved it was false, basically. I'm going to let you do those two. So basically what it's asking you, it says whole numbers closed under division. That means, can two whole numbers be divided and give me a whole number? I want you to figure that out. And then odd numbers are closed under addition. Can I add two odd numbers and get an odd number always? If you can find a counterexample, that means it's false. Okay? And that will be it for this video. We'll go over more stuff in the Google Meet. But then we'll also probably work through some of this homework. I would like you to begin on the homework. I'm sending you all of this stuff. So work through the homework, see what you think. Try to get it all done. Then we'll discuss it in class in the Google Meet.